Let's take a look at what is the domain of a function. So what do we mean by domain? What does that mean? We said that's the x value. So if we're talking the x value of a function, as it says, domain states what the x value can be. So what would we say is the x? What could it be in the function f of x equals x minus 5? What could we plug in there? Is there a restriction? I mean, is there something I can't plug in? I can plug in anything. I can plug in 7. 7 minus 5 gives me an answer of 2. Every x I put in there will produce an answer. Every one of them. That would tell us that actually domain is all real numbers. That's the symbol for all real numbers. Just make 2 lines. You know how your teachers go like that to say, oh, new paragraph? Well, we do it for all real numbers. They stole it from us, the math guys. So that's the symbol for all real numbers. So let's decide if 5.5 is part of the domain for these items. Could 5.5 be a domain for the number of girlfriends I have? First of all, we know I have no girlfriends other than my lovely wife. But yeah, you can't have 5.5 girlfriends. That doesn't make sense. So the domain there, no, 5.5 couldn't be the domain for that. What about the number of pieces of pizza I ate last night? Yes, 5.5 slices. I ate 5 and then I ate a half a slice. Yes, that could be the domain. That could work. What about the number of masks I wore today? Can you really wear 5.5 masks? No, you can't wear half a mask. And don't say, oh, well, you could tape one on. No, 5.5 is not the domain for the number of masks I wore today. So I'm trying to get you to think, okay, the domain is simply what can work, what can be plugged in to work. So what did we say was the domain for this? We said everybody works. There's no restrictions. Okay? You could plug 5.5 in here because we're not talking the number of masks or girlfriends or slices of pizza. You could plug 5.5 in here. You could plug 5.1 in here. You could plug 6 in here. We said everybody works for that. Okay. So when would there be a restriction for what x can be in a function like that f of x? Well, fractions create a problem since the denominator can't be a 0. So what would we say is the domain of this function, x divided by x minus 4? Oops, I scrolled a little too far. I can plug anything in there. 6 would work. I mean, I could do 6 divided by 6 minus 4. That's 6 over 2. That gives me an answer of 3. I could plug 10 in there. I'd get 10 over 10 minus 4, which is 6, which should give me 10/6, which what? Simplifies to 5/3. But wait a second. I could plug anything in there except for one problem. What if that guy's a 4? 4 over 4 minus 4 is 4 over 0. Uh-oh, we got trouble. So what happens is in a fraction, we say, hey, you could be anything. Everybody works except for we cannot let that bottom part in the denominator, we cannot let that guy come out to be a 0. So if we simply solve it, you and I can see x can't be a 4. We can't allow it to be a 4. So we would say the domain is all real numbers except x can't be 4. And the way we would write that is all real numbers work. In other words, everybody works except x cannot equal a 4. That's how we do a problem like that. Whenever there's a fraction, we simply take the denominator and say, hey, you can't be 0. Every other number is going to work. Everything can work except that value. So let's state what the domain of this is. I can plug in any x. All types of x's will work. 7, -4, 1 million, 2 billion, 2.1. They'll all work. Everybody's going to work. But we know that bottom piece, this right here, cannot come out to be a 0. We can't let that happen. I can see that 9 is going to be a problem because 2 times 9 is 18, and 18 minus 18 is going to give me a 0 there, and that's going to mess the problem up. So what we do is we simply always take a fraction, say, hey, the denominator can't be 0, and then we simply solve it. And in this case, I made it an easy equation for us. We can see divide by 2, x can't be 9. So we would state that the domain is all real numbers work except don't let this guy in. X can't be 9. He's the one guy that it can't be. So that's what we would say the domain is for that. What else is going to create a problem besides a fraction? A square root creates a problem. How? What's the problem with a square root? I mean, well, let me ask you, can you take the square root of -8? No, it becomes an imaginary number. So we can't take the square root of a negative number. So how are we going to figure out what our domain is? What can X be? X could be 10 here. That'd give me this 10 minus 7 is 3, square root of 3. What we need is we need to make sure whatever's underneath here stays bigger than or equal to 0. In other words, we can't have a negative. So what can it be? We simply say, hey, what's underneath there needs to stay bigger than or equal to 0, because you can take the square root of 0. Otherwise, you're going to have a negative number in there, and you can't take the square root of a negative without dealing with an imaginary number. And we're talking just real number solutions here. So in this problem, we say, hey, everybody that is bigger than or equal to 7 works. Now, the way we write this is we say it's all real numbers such that X is greater than or equal to 7. That's how we do them. So, in conclusion, what we have is there are only 2 places where our domain gets restricted. Fractions, and when we have a fraction, we set a denominator, we say you can't equal 0. Everybody works except for that bottom denominator cannot come out to be 0, and we solve it. For a radical, for a square root that is, we set it to be greater than or equal to 0. We can't let it be negative. So we say, hey, everybody works as long as this guy is bigger than or equal to 0. All other times, if it's not a fraction nor a square root, the answer is always going to be, for what we're doing, all real numbers. Everybody will work. There we have it. Now again, you can look, I've done all homework problems. I did a video for every single one of them, so that should help you. This is a section where students struggle. I don't know why, to be honest. Never figured it out, nor have other math teachers. Very simple. If it's a fraction, the bottom can't come out to be 0. If it's a square root, hey, you got to stay bigger than or equal to 0. Those are the only 2 things we have to worry about. Just don't get them backwards. Just think it through.